All right, let's just jump right in. I want you to imagine for a second everything you've ever seen. Every star, every galaxy, every single planet. Now, what if I told you all of that is just a tiny, tiny fraction of what's actually out there? And no, this isn't science fiction. This is maybe the central mystery of modern physics. You see, most of our universe is, well, it's missing, and we are on the hunt to find it.
And this is what's so mind-blowing. Take a look at this chart. It's incredibly humbling. You see that tiny little sliver? Less than 5%? That's everything. Everything we're made of, all the stars, all the galaxies. It's just ordinary matter. Then you've got this huge chunk, almost 73%, which is this bizarre force called dark energy that's pushing the universe apart. But that other big piece, that nearly 23% slice, that's our target. That's dark matter.
Okay, so the best way to think about this whole thing is like a detective story. We've just rolled up to this massive cosmic crime scene. The victim? You could say it's our entire understanding of the universe. And the missing item? A truly enormous amount of matter. Stuff we know has to be there, but we just can't see it. And here's the scale of the problem we're dealing with. Get this, when you ignore dark energy and just look at the matter in the universe, scientists are pretty sure a staggering 85% of it is dark matter. 85%! It's this totally invisible substance that doesn't interact with light at all. So we can't see it, we can't touch it. The only way we know it's there is by its ghost, this powerful gravitational pull it has on everything we can see.
So this really boils down to two main possibilities, and this quote just nails it. It's one of two things, right? Either there's a totally new, invisible kind of matter out there, what we're calling dark matter, or our fundamental understanding of gravity, the laws of physics themselves, is just plain wrong. And while that's a possibility, for now, pretty much all the evidence is pointing to something being out there, lurking in the shadows.
Okay, so if we're detectives, we need clues, right? We need evidence. And even though we can't put dark matter under a microscope, it's left this incredible trail of undeniable clues, these cosmic footprints, all across the universe. And these are the clues that scream it has to exist. All right, clue number one. Galaxies are spinning way, way too fast. I mean, when astronomers look out there, the stars on the very edges of galaxies are moving at incredible speeds. So fast, in fact, that based on all the matter we can see, they should just be flung off into deep space. It's like a kid on a merry-go-round that's spinning out of control. The only thing that can explain why they're held in place is a massive, invisible halo of matter, providing all this extra gravitational glue. And then there's clue number two, and this one is wild. It's called gravitational lensing. Basically, Einstein figured out that really massive things bend space itself, and so light has to curve around them. And we see this happen. We see light from super distant galaxies getting warped and distorted as it passes by other stuff. But here's the kicker. The amount of bending we see is way more than the visible matter can account for. Something else, something massive and invisible, has to be doing the bending. And these huge, unseen clumps of mass, they fit our dark matter models perfectly. Okay, and our third and final piece of evidence, this might be the most powerful one of all. It comes from the oldest light in the entire universe, the cosmic microwave background. Think of it like a faint baby picture of the universe left over from the Big Bang. Now, the tiny little temperature spots in this picture are like the universe's original blueprint. And when we run the numbers, the patterns we see, they only make sense if there was about 5 times more dark matter than regular matter, right from the very beginning, acting like a cosmic scaffold that allowed galaxies to form in the first place.
So, you see, the evidence is pretty overwhelming. Something is definitely out there. Which brings us to the next big question for any good detective. Who are the suspects? What in the world could this dark matter actually be?
Well, for decades, our prime suspect has been a particle called the WIMP. That stands for Weakly Interacting Massive Particle. It's a hypothetical particle, probably about as heavy as a proton, and just like its name says, it barely interacts with anything. I mean, billions of them could be streaming through your body right now, and you wouldn't feel a thing. They're kind of the perfect candidate, right? They're massive, and they're invisible.
But hey, the WIMP isn't the only name in the suspect lineup. On the complete opposite end of the scale, you've got axions. These are also hypothetical particles, but they are incredibly, incredibly light. And this comparison just shows you how tough this investigation is. Our cosmic culprit could be a heavyweight like the WIMP, or a total featherweight like the axion, or something else we haven't even thought of. The search has to be ridiculously broad. So, with a couple of prime suspects in mind, the investigation goes global. I'm talking a full-on worldwide dragnet. Physicists are using 3 totally different strategies to try and finally catch one of these elusive particles and crack this cosmic case once and for all.
And this diagram really lays out the whole game plan perfectly. It's a 3-pronged attack. First, you have direct detection, which is basically trying to catch a dark matter particle red-handed as it hits one of our detectors. Then there's indirect detection, where we look for let's call it the crime scene, the aftermath of dark matter collisions way out in space. And finally, accelerator production, where we basically try to build it ourselves. Let's start with the first strategy, direct detection. The idea sounds simple, but trust me, the execution is absurdly difficult. What you do is build the most sensitive detector you can possibly imagine, bury it a mile underground to protect it from all the other cosmic noise, and then you just wait. Seriously, you're waiting for that 1 in a billion chance that a WIMP, after flying through the Earth, will just happen to bump into a single atom inside your detector and cause a tiny, tiny flash of light.
And this is what one of these things looks like. It's wild. Experiments like this one, RDM, or another big one called Lux Zeppelin, use these giant vats filled with super pure liquid xenon or argon. You can think of them as the most sophisticated listening posts ever built by humans, designed to hear the absolute faintest whisper of a dark matter particle as it drifts by. All right, strategy number 2 totally flips the script. Instead of waiting for dark matter to come to us, we go looking for its wreckage out in the universe. The theory here is that in places where dark matter is super dense, like, say, the center of our galaxy, 2 dark matter particles should occasionally smash into each other and annihilate, basically exploding into a shower of other high-energy particles like neutrinos or gamma rays. And how do you spot those signals? Well, you use something colossal, like the Super Kamiokande detector in Japan. And when I say colossal, I mean it. This is not your backyard telescope. It's a 50,000-ton tank of ultra-pure water buried deep inside a mountain and lined with thousands of light detectors. It's basically a giant artificial eye, just watching and waiting for the telltale flash of a neutrino that might have traveled all the way from the center of the sun or the heart of the galaxy, carrying the signature of a dark matter collision. And that brings us to the third, and maybe the most audacious strategy of all. The motto here is pretty simple. If you can't find it, build it. Scientists are using incredibly powerful particle accelerators, like the famous Large Hadron Collider, to smash protons together at just under the speed of light. The hope is that in that massive explosion of energy, they might just create dark matter particles. And the signature they're looking for? Energy and momentum that just vanishes. Poof. Gone from the detector, carried away by our invisible suspect. So, after all this time, after decades of searching with these absolutely incredible experiments, what's the verdict? Where does this cosmic case stand? Well, to put it mildly, it's complicated. The case is still very, very much open. And this right here, this captures the central puzzle of the entire search. On one side, you have this mysterious, incredibly tantalizing signal from an Italian experiment called Gamma/Libra. For over 20 years, they've seen this signal that waxes and wanes with the seasons, exactly what you'd expect if the Earth were plowing through a halo of dark matter. But, and this is a huge but, nobody else has seen it. On the other side, you have the results from even more sensitive experiments, and they found a wall of silence, nothing. As you can see from those lines pushing further and further down, these experiments have ruled out a whole bunch of the simplest WIMP theories.
So where does that leave us? You might think it's a dead end, but it's not. We haven't found the smoking gun yet, that's true. But the search is far from a failure. In fact, every time an experiment like LZ comes back with nothing, that's actually super valuable data. It lets us cross suspects off the list. It helps us narrow the search. The dragnet is tightening, and it's forcing physicists to get more creative, to look at other suspects, like those featherweight axions, or maybe even think about new ways dark matter could be hiding. And you better believe the next generation of even more powerful experiments is already being planned. You know, when you step back, this is truly one of the most profound quests in all of science. For our entire history, we've studied the universe by looking at the light, by looking at what we can see. Finding dark matter wouldn't just be about discovering a new particle. It would be like opening a door to a whole new dark side of the universe that we never knew existed. It would fundamentally change our place in the cosmos. And that leaves us with one final incredible thought to ponder.